So it is very nice to meet all of you for this kick-off meeting of Euphresco Basic project. And in the next hours, we will start to talk about the basic substances and what we can do in the next few years on this subject. But I welcome to all of you, but before to start, I give the floor to Valdisera Giovanni, that is a Euphresco coordinator, that will give us some instruction on what we can do and how we can do at the best for the next time. Welcome, Valdisera.
Thank you, Gianfranco, and thank you, everybody, first of all, for your passion. I can see that you're passionate because you wake up at 5 in the morning to attend this meeting. I'm so pleased with this group. You know, my work is to bring people together and to have them working together, and then I try to support whatever comes out from the project and to increase the visibility and the use of the research outputs. And I have to say that I've rarely seen, first of all, a coordinator as Gianfranco, and then such a big consortium of scientists. So for me, it's, I mean, you give me a reason to continue to work on Euphresco. So Euphresco is a very flexible tool. We are not here to give you what to do. I like to say that Euphresco is a service a la carte. It's like a menu when you go in the restaurant. You have a choice of dishes and you pick up whatever you want to eat. And the projects are the same. You are participating with your funds by aligning research activities that you may already have planned or that you are just starting for the Euphresco. So it's really up to you to decide what you want to share with the community and what you want to pick up from this group. I would say that the only recommendation I can make is to cherish the coordinator, because projects exist because of the work of the coordinator that keep the group alive and ensure communication between all of you. And obviously, I will try to do the same, but behind the scene. So you will not see me, but I will always be behind Gianfranco to support him throughout the project. And that's all I want to say. Of course, if you have any specific question, I would be pleased to answer, but I think it's now time to stop talking administration and to focus on science. Thank you very much again.
Thank you, Valdisera. You are very kind, but I'm sure that we will see you very often, and the project will be alive with all the people, because everybody of us will carry a little bit and will dedicate a little bit of our time to this shared subject. And I hope that we will build something small, even small, during this time. And now, after this very short presentation, I think we can organize the day and welcome to the people that connected after the starting with the presentation of some of you, because a very short presentation, 3 to 5 minutes, not so long, just to give an idea to the other participant what we can do, what we do in this subject, and So everybody can have a feedback, and after the presentation, and some of the participants will join us later. After the presentation, we can discuss on the VP and the VP responsibilities and what we can do and how we can arrange the work for the next period. So, Valdisera, in case you have to go, and we know that you are very busy, feel free to go, and thanks for coming and being with us. And since Euphresco is a very big plant, but is under a bigger umbrella. This umbrella is HEPO. So I will give the floor to Eva that will introduce very briefly HEPO activities.
Thank you very much, Gianfranco. I have a presentation. Do you wish me to?
Yeah, sure.
Yeah. I'm not sure how to start the presentation.
On the bottom, it should be a green
share screen. Okay.
Screen.
Yes. Thank you very much. Is it fine?
Yes.
Okay. Thank you for the opportunity to give to presenting EPO to participants. Just very shortly, I would like to introduce EPO. EPO is sorry. What is EPO? EPO is abbreviation from European and Mediterranean Plant Protection Organization. We are intergovernmental organization, and just this year we celebrate 70 years of 70th anniversary. I think it was in April when EPO was created in 1951. Currently, EPO has 52 member countries, and on this little map, you can see that the member countries of EPO are also in Western Asia and Northern Africa. EPO works in international cooperation in plant health in two main areas, plant quarantine and plant protection products. EPO works for and with national plant protection organizations. What does it mean? It means that in every member country, our contact points are national plant protection organization. What is the relation of EPO to the European Union? All EU member states are EPO members, but EPO makes recommendations which are voluntarily taken by countries, while EU works on the area of EU but prepares regulation which must be followed by member countries. As I said, EPO has two main areas of work. I'm leading EPO program on plant protection products. Obviously, I would like to talk more about plant protection product area of work of EPO, but EPO also works in the area of plant quarantine. Regarding activities on plant protection products, we mostly, our main focus is on producing standards on plant protection products efficacy evaluation. So far, we produce more than 320 standards. Also, we work on resistance database, which I hope will soon be launched if the Council will approve. We work also on harmonization of data on plant protection products. EPO produce EPO codes which to describe different types of crop and pest species, but what is important in the area of plant protection products, that EPO codes are also on the plant protection treatments. EPO produce minor uses extrapolation tables, and soon we will start work on a database based on these extrapolation tables. Sometimes we also organize workshops. What is important that EPO succeeds through collaboration between experts in the region and beyond the region. And if there are any EPO expert who listen to this presentation, I would like to thank you very much. The knowledge and what we gather, we distribute through different information services. We have a website, Twitter account, Facebook account, and if you are interested, please visit our website. There is very many interesting information, or follow us on Twitter. This Twitter account is dedicated especially for plant protection products. So as you can see, EPO is not a research organization, but we have a lot of contact and a lot of expertise, and this we can offer to the project. Thank you very much.
Thank you to you, Eva, and it is great to have a EPO within the project, and we will discuss maybe later on, that can be in the afternoon, so we can plan to stay together till 1 o'clock or so, and later start again around 3 p.m. In the VP, last of the VP is on dissemination. And we can arrange together a way to disseminate all those information with social media or with creating a website. And we will see how, when, who is able to do it, and what space and time. And I think this is very important to cluster together all those information. So thanks, Eva, and thanks, Baldissera, for your presentation introduction. If you agree, I will show just a few slides about our activity. And where is... Okay, so yes. We are 30 teams with several people per team. So it looks like we are a big bunch of people from 16 different countries, and our time summarized more than 600,000 euro. It means that we can do a lot of things together. And some of the teams has different activity in which can be involved. And we just proposed, it's just a proposal. We can discuss later about this. We can include more or delete some. But we draw, and Marwa gave a big hand in this kind of activity. We draw the VP, a list of VP, also copying from other Euphresco project already approved, asking to all of you which VP you want to join. Then you send us your selection. Of course, this is not written on the stone. You can change, you can add, you can delete, because here there is the title of OP. But today in the afternoon, we will discuss, or even later, what we can do per each VP, and maybe some of you can reverse their first choice. Then, what we are doing within this area, for example, we are working with some of you in a project linked to reduction of the waste. It's called the Stop Med Waste. It is a PRIMA project funded by PRIMA Foundation, where we have some experience on the application of this chitosan, that is a biopolymer with different activities, so antimicrobial, eliciting, and film forming. And this can be a different weight because it is clarified that it is antimicrobial activity run after a meta-analysis. It is sure that it has antimicrobial activity. Eliciting activity depends on the time and depends on then the pattern that is elicited. We have some experience also in the essential oil and on potential other basic substances, and we will discuss later on which can be the potential basic substance, because there is a list of approved compounds, and Patrice will talk us about them. There are 23 nowadays. Some others may be on the list. Some others may be proposed as a basic substance. And so we are studying effectiveness and the mechanism of action. And also we are spraying some of those compounds. For example, with Petson, we are getting good results. Spraying into the field, onto the grapes, onto the canopy for the control of grape vine down mildew, and we are getting good results about this. It is comparable, the effectiveness to copper, and copper may be taken away by the market because it is a candidate substitution. This can create a big hole in the protection of plants in organic agriculture. So we know that in one hand, EU wants to promote organic agriculture, but if we reduce the copper and we don't have alternatives, it will be very difficult to do so and to reach these 25% of average of organic agriculture, and also reduction of synthetic pesticides. All those activities can improve the activities of the basics projects can improve the availability of alternative to synthetic pesticides. We are also working in cooperation with INRAT, and here there is Professor Allagui, on the antimicrobial activity of essential oils toward seed-borne pathogen, and in vitro and in vivo, and Marwa worked a lot on this issue. And we have a project that is called Clean Seed for the application of essential oils and other alternatives to synthetic fungicides to vegetable crops for the production of seed. Project is just starting, and we will provide news in the next calls. So this is more or less the teams, and Marwa worked a lot for this project. Lucia worked on mechanism of action. There is Lucrezia, Simone, and a list of other, Sergio, and a list of other colleagues that contribute to those activities. And now I stop my presentation, and I ask Patrice Marchand to show briefly his activity. Welcome, Patrice. I don't know why, but we cannot hear you. Look on the bottom corner, or take away the plug. Maybe, Patrice, you can just try to set up again your system, and I will invite you soon again. And now I can invite José from Brazil just to show quickly his expertise on basic compound. How, José? Good to see you.
Good to see you, Professor Romanazzi. Thank you for the invitation, and thank you, Professor Baldissera, for the organization. I'm José Pinzetta. I'm a PhD student from Unesp Jaboticabal. I will share my screen. And today I'm on behalf of Professor Benhur Matheus, which is my supervisor, and he couldn't be here. So I will show you the presentation of him. I'm sharing already. Just a moment. Okay, so Professor Benhur Matheus, he is professor since 2002 from Unesp. He has done his postdoc in France, Montpellier. Our research fields is in post-harvest of fruits, vegetables, and flowers. He has been doing international collaboration with researchers in Canada, France, Honduras, Mexico, Italy, and Spain. And so far, he has supervised 14 doctoral dissertations. Just to situate where we are located in São Paulo State. São Paulo State represents 32% of Brazil's GNP. So it is the first economy state in Brazil. And we are the 30th economy in Latin America. So it has a very economical importance for Brazil, the São Paulo state. Our institution is UNESP. UNESP is São Paulo State University. UNESP has 45 years old of foundation, but before the foundation, there were independent institutes across the state. So some of these institutes are older than the university. UNESP has these characteristics of being situated in every part of the state. So you can see we have campus in all the parts of the states. We have 136 undergraduate courses and 149 graduate courses, and we are the second most important university in Brazil. Just to situate where Professor Binur is located, he's located in Rio Claro city. Rio Claro is a city of nearly 200,000 people. The UNESP campus in Rio Claro has 10 undergraduate courses and 4 graduate programs. So we have been working on post-harvest of fruits, vegetables, and flowers. One of our research focus are the use of hyperbaric pressures for improving conservation and disease control. So we have some publications so far with tomato and also with mangoes, but we are working also with guava and tomato with the end of controlling diseases. Another research focus of ours is the use of edible coatings and essential oils for post-harvest conservation and disease control. So we have some work conducted with mango, with guava, and also with mango, and we have some works with strawberries, and this is our 2 main research focus. Our funding comes from FAPESP, São Paulo Research Foundation. São Paulo Research Foundation receives 1% of all the state taxes, so it has a considerable amount of money to funding research, and the research funded by FAPESP represents 45% of the country's scientific published articles. So if you need more information or want to establish a contact, here is the email of Professor Matheus. Thank you for your attention, and thank you for Professor Romanazzi for the invitation for the project.
It is our pleasure, Jose. Thanks for your great presentation. And I think that this project can be an opportunity for exchange of information among all of us and then some cooperative works. Patrice, do you want to try again?
Yes.
Very good. We hear you.
Sorry. Okay, so I can share my screen. Where is the screen?
On the bottom. It should be a green button.
Yeah. Go for it. Okay. So I can show the people involved at ITAB. Jan would be responsible for some trials, and maybe next year he would come to your place to test those basic substances in the field. Leah was just coming 2 months ago, and she would work on the regulatory pathway as myself. So, as you know, the basic substances are plant protection substances under regulation EC 1107. They are here basic substance. I'm going to pass rapidly on the definitions since most of you have seen those previously, but most of the time they are totally out of concerns in all compartment, human and field ecotox. That's the pathway. Actually, it's going to change since now the deposit would occur through EFSA via a new software via Euclid. So it's going to be more tricky, but anyway, we are going to make it So steps are clear: admissibility, questions, approval, and transfer inorganic production when it is necessary, and sometimes for the minerals it is necessary. So that's going to change. Approval time is around 2 years, a bit more than 2 years now. That's an average. Some are really fast and some, like talc, are really slow. That's the timing. So basic substance or active substance. So that means you need what you do in the field to determine the gap table, the usages, as EPPO are maintaining those field trials guidelines. So you know all those gap tables with crops, targets, condition, application, delays, and stages. Here at the 23 approved basic substances and 17 were done by ITAB. Those gray, those light green are still not allowed in organic production, like clay charcoal and talc, and all the food stuff are coming straight to organic production, allowed in organic production. Here are some examples of the usages. So don't limit yourself. Everything is possible inside the basic substance. Here at the second row, and that's the last ongoing results. So we just got the allium cepa extract in January, and it's maybe useful. And unfortunately, most likely we are not going to have these willow stem and bark extracts in order to get auxins for the small, tiny plants. And there was another dimethyl sulfide ongoing for non-approval, most likely next week. And I'm sorry for that, because it was useful for some as some attractant in traps. So I found that strange that it's not going to be approved. So finally, up to now, 46% of the full dossier were granted, approved, and a lot of them, 55, were either removed, withdrawn, or in red, non-approved. This is the curves for basic substance in conventional agriculture, and here in green, of course, basic substance in allowed in organic production. So as soon as we have this direct transfer in 2016 for food stuff from animal and vegetable origin, you understand that most of the basic substance goes straight to allowance in organic production. And next is just a few papers. This would be available in the next by John Francisco, who would make this available for everybody. And we have also the website from ResearchGate, where all the approvals and all the extension of uses are up to date, I guess, up to now. So every time we get a new report review, everything would be put on these pages.
Thank you, Patrice.
You're welcome.
We will discuss later in the to-do list, and yes, your contribution will be very important when we will define which can be the candidate basic substance, starting from the non-approved one, maybe, or on the criteria. So we will have a discussion later. And your idea was great. The PDF that you have can be uploaded on the ResearchGate page. Okay. So everybody can, you can send us the PDF and we can upload there. Thanks again. And now
Welcome.
let's move on the other side of the globe. There are Dan Dan and Xiao Meng from China. I don't know if you want to. I think it is night by your side, Dan Dan. Hi, Dan Dan. Hi, Xiao Meng.
Hi, Professor.
Hi.
What time is
Hi,
there?
Professor. Hi, Professor.
What time is by your side?
4:30 p.m.
Okay. So a double welcome to you. If you
Okay.
want to, even if you work on two different institutions, if I catch well, you are cooperating, right? So if you want to show together or separately what you have in mind to do, feel free to do it.
Okay, I will show my PPT. Uh-oh. Okay.
Go on the bottom and click the green. Okay, very good.
Can you
Yeah.
Okay. Can you see the PPT?
Sure.
See the screen?
Sure.
Okay. Okay, hello friends. My name is Guo Xiaomeng and my partner, she is Dan Dan. I'm a postdoc from South China Agriculture University, and Dan Dan is a postdoc of Shenzhen Polytechnic. Firstly, I want to thank Professor Romanazzi for inviting us to join this interesting project. We want to introduce our plan to you. We want to do the effect of cathodin and salicylic acid on the control of post-harvest disease of lychee. Because me and Dandan, we are working in the China lychee and longan research system. So it's better to do lychee and we can do this experiment together. And now I will introduce lychee. Lychee or lychee is a subtropical to tropical fruit with attractivity, appearance, and fascinating flavor. The shelf life of lychee fruit is very short, only 2 to 4 days at ambient temperature. Pericarp brownie and post-harvest decay were identified as major problems. You can see this picture. The fresh lychee is very beautiful and delicious. But when we after harvest, we can see the physiological pericarp browning and post-harvest decay. Lychee downing blight and lychee anthracnose disease is a major decay in our area. Because the lychee harvest season will coming, so we have a plan. We want to do the cathodin and salicylic acid to treat the lychee. They are in our basic substance number 2 and 11, and we found some researchers. They reported the cathodin or salicylic acid have some good effect to lychee, but only one paper mixed them, and this paper focused on the quality and quality of the fruit and pericarp brownie. We think we can do something about the decay. So our aim is to know the effect on the control of post-harvest lychee decay and the pathogen biology characteristic. If we have some good results, we can know some mechanisms on disease resistant or inducing resistant. Finally, welcome to Guangdong and welcome to China. We are here, the star. Okay.
Thank you, Xiaomeng, and thank you, Dan. And who knows that one day we don't meet in China, in Guangdong for a project meeting. Who knows? We have a couple of years. We can plan a lot of things to do. Thank you again. Now we can go on the other side of the world. So, Yaimi from Colombia.
Hello, how
Hi,
are you?
Amy.
Can you see me?
Yeah, of course.
Okay, thank you so much. Can you see my presentation?
Yeah, sure.
Good morning, everybody. I am Jamie Peralta, professor of the Universidad del Atlántico, Colombia. I am chemical engineering, master in science in chemical engineering, and currently I am a PhD student of food science in the Teramo University. Our university is located in Colombia, a country of South America, bounded of the north by the Caribbean Sea and the west by the Pacific Ocean, in Barranquilla City, located near to the Caribbean Sea. Barranquilla is now has Colombian Golden Door. It is famous for its carnival declared by UNESCO masterpieces of the oral and intangible heritage of humanity. The Universidad del Atlántico is the largest higher education institution by a student population in the Colombian Caribbean. Currently, we have 25,000 students, 4 campus, 10 faculties, 41 underdegree programs, 25 postgraduate programs. I am part of the Agroindustrial Research Group of the Agroindustrial Engineering Department. The research goal of GIA is to create an enable environment for the development of agribusiness, agroindustry, and agro-based value chains in Colombia. Our team is comprised of very different professors in the areas of science and food technology and engineering. In the areas how agroindustrial design processes, food technologies, food security, and post-harvest technologies. Regarding to research goals and objectives of our group, specific areas of research insights include biotechnology, agriculture and food marketing and distribution, design, evaluation of agroindustrial processes, food safety management, and packaging, storage, and conservation system for agricultural and agroindustrial products. Currently, we have 231 research products. In our group, I have 2 research incubators, and in this moment, we have excuse me, 60 students, young researchers. In this moment, we have emphasis in ketose and bases coatings containing essential oil for apply in different fruit, in different tropical fruits, have guava, papaya, tomato, and other. In this opportunity, we have contributed for the work package 1, 3, and 4 with the evaluation of the effect of ketones and coatings and properties on fresh fruits and vegetables, evaluation and characterization of commercial fungicide mixture with ketose and hydrochloride for possible field application. This activity will be performed in cooperation with the Polytechnical University of Marque. And ketose and the study of ketose and basic coating, how the antifungal activity and application, how as post-harvest strategy in tropical foods in cooperation with the University of Teramo. Thank you for your attention. Thank you so much for the invitation to the project.
Thank you, Yaimi, for your very great presentation. And you give a view of another side of phytopathological situation and problems that affect also tropical fruit, and we need to afford and take in mind. Moving back to Europe, we can fly to Hungary with Professor Elisabeth Carafa, together with Xilla, Kata, and Andras. Elisabeth, the floor is yours.
Thank you. And first of all, thanks for the invitation for Gianfranco. I am trying to upload my slides. Okay. Okay, so I hope you can see my few slides nicely. I greet everyone here from Hungary, which is a Central European country not very far from Italy, so we are at the same time frame. I am from the Faculty of Agriculture and Food Sciences and Environmental Management, and my just finishing PhD worker is Kata Mihai, who will participate in this project together with András Csótó, who is my colleague and my PhD student as well. And another institute of the University of Debrecen, Gyula Kovács from the Institute of Agricultural Research and Educational Farm will also participate. And she was my former earlier PhD student. He has defended just 2 years ago her PhD. So we greet all of you, and Debrecen is in the eastern part of Hungary, close to Romanian border, and maybe only the German ones knows from Debreciner, which is a sausage and was created here. Very close, there is not very far from Debrecen, there is the famous Tokaj wine region. We have got some research field there, and near to Debrecen, it's famous from sour cherry production as well, which is the 10th most highest in the world. Regarding that, Hungary is not a very big country. It's a very important fruit crops. So we will work on 2 crops, on grapes and sour cherry, or you may know as tart cherry as well. It's a Prunus cerasus. We have got collection of culturable pathogens from grapes. We would like to test mainly chitosan as a basic substances to protect and check their inhibition potential. We have got a collection of potential biocontrol agents, and we would like to test the effect of chitosan on them for the further possible applications in organic plantations. We have an orchards for research. I showed you that it is in the Tokaj vine region, but we have got some plantations at the university as well. In case of the stone fruits, we also have got collection of culturable pathogens. It has been mentioned Colletotrichum. We has problems with Colletotrichum as well, and we would like to check the chitosan effectivity against it. We have a capacity for shelf life studies and storage as well in case of stone fruits. So we would like to test the potential for chitosan mainly as a post-harvest treatment. And we have some preliminary results about the pre-harvest chitosan treatments for the effectivity of the storage and shelf life of the sown fruits. And we also have orchards for research in the neighborhood. We will test mainly grapes, the effectivity of downy mildews based on Gianfranco's previous works. And we, as we previously worked and still working on grapevine trunk diseases, we would like to check the effectivity of mainly chitosan against the pathogens and for the symptom appearance, and maybe other diseases. It depends on the season which can be detectable. In case of stone fruits, we mainly focusing on the post-harvest decay agents, and if there's going to be other diseases, we will also evaluate them, of course. So thank you for your attention, and I hope that next time we will be able to meet not online only, but maybe personally as well.
Thank you, Elizabeth and colleagues, and also Hungary, as all the other one, can be a good place where to meet. We have plenty of possible options, and we will try to do our best in the near period.
Yes, you are welcome.
And now is the turn of Professor Antonio Ippolito from University of Bari. Welcome, Antonio.
Hi, Gianfranco. Hi, everybody. First of all, thank you, Gianfranco, for inviting us to join this really interesting project. You are jumping in every part of the world, from the north to the south, east, west. So it's really very widespread. And yeah, my presentation is really very short. Let me see. Okay. Yeah, we are a little group now, just me and postdoc Anna Maria Mincuzzi, and in this period we have worked on some substances that can be interesting for this kind of project. Just as expertise of my group that started to work on this on post-harvest just many years ago, at least 30 years ago. And I remember that Gianfranco started working on chitosan as a doctorate in my university, and he continued. So honor to Gianfranco for this activity that I really appreciate. That chitosan, his thesis was on chitosan, is used all over the world. And maybe a very important stone was posed by Gianfranco, I think almost 20 years ago, I think. Our activity is
even more, unfortunately.
Also more, okay. Our activity is based on the use of physical means during UV pressure, different from the atmospheric pressure that was an activity started by Gianfranco, electrolyte water, ozone, biological control, natural substances, among which clearly chitosan, extract of plant and animal origin, organic and inorganic salts, carbonate, bicarbonate, and so on. And also diagnosis and quantification of different kind of pathogen and the mechanism of action of these alternative control means. Yes, we can say that they are alternative control means. And okay. Our activity was capitalized in different kind of papers, and just to show something of that of these papers, research activity, review on published on papers on a journal, and also book chapter. In this period, we are working just to be in this project with chitosan. And sodium bicarbonate on what kind of commodity? On pomegranates, on sweet cherries, on citrus, and on table grape. We have at least two projects on this, and so we can implement these results with the Euphresco. But we have something prepared also in this year with additional substances with the use of red algae extract and the use of electrolyzed water. About the red algae extract, we had some results, interesting results with the sweet cherry, and we are repeating these kind of trials also this year. Although we had the frost damage, so we don't know if we will be able to obtain results this year. And as you can see here, red algae alone or in combination with other substances were among the best one, comparable with chemical control, especially against botrytis and other fungi. We had some strange results, not clear results about monilinia. It means that red algae were not active on two kind of varieties on monilinia, and so we have to understand why this kind of result. Also, another possible additional substance can be the electrolyzed water. We worked some years ago, but we are starting again. We are continuing this kind of activity. And we have, for example, this result, interesting result on electrolyzed water in presence of sodium bicarbonate. The natural population in washing water after 1 hour was reduced drastically and remained very low, this kind of population in water, in washing water, although tons and tons of oranges, sweet oranges, passing through the chain. So we have, for example, in this case, a little increase of population because in that moment passed a lot of fruits, very contaminated with a lot of mold, penicillium on that. And so, although this kind of technology, this kind of water is still not registered as a biocide, could be a potential to be utilized in next future. Another just visible aspect of the water at the beginning of electrolyzation was dark, but at the end, although the chain was working, at the end of the activity, after 1 day, it was again clear. So this is a very interesting possibility to be utilized as additional substance. That's all. Maybe I forgot, I'm from Italy. We are from Italy. We are at the southern part of Italy. Gianfranco is northern part, the most important part of Italy, but also southern Italy is very important. We are at the end of the booth. That's all. Thank you very much for your attention. Bye-bye.
Thank you, Antonio, for this very interesting data, and I'm sure that it will be room for discussion when we'll tell what we can do, so which can be the activity that we can run. So let's move to Alessandra De Francesco. I saw she's connected. Alessandra, are you with us? She's connected, but I didn't see her face. Here he is. Hi, Alessandra. Welcome from Germany. Now.
Yeah, but I come from Italy.
Yeah, we know you. How are you?
Fine, and you?
Very good, very good.
I hope that you are fine. So I charge my presentation.
We saw you in a field, right? In a field on the sea.
Oh, maybe because I charged the screen, but I'm in the lab.
Okay.
Maybe. Okay. Can you see my presentation?
Yes.
Perfect. I'm Alessandra Di Francesco. I'm a postdoc from Bologna University. Maybe you know Bologna is in the northern part of Italy in the region Emilia-Romagna. And this university is known to be maybe the oldest university of the occidental part of the world, because it was active starting from the 11th century. I work in plant pathological sector and in the Department of Agricultural Sciences. Mainly, my research was ever focused on the use of biological control agents and the study of their mechanism of action, such as the antibiosis, plant defense induction, or competition for nutrients and space, but also with my old supervisor, Marta Mari, we studied also hot water treatments on peaches and on apples to control a very common pathogen latent pathogen, fungal pathogen in Italy of peaches and on apples. I'm very enthusiastic to participate to the Euphresco project, so I thank you very much, Professor. And about our project, we decided to study in the WP4 the use of some products to control some post-harvest fungal pathogen diseases. In this case, we focused our research on kiwi fruits and palm fruits, and our target pathogens will be Cadophora luteolivacea, that is starting to be a very common pathogen in the storage in Emilia-Romagna, so it's becoming a great problem for us, and nobody knows the real epidemiological cycle of this pathogen, and now we are trying to understand this and try to apply some control practices. And then we want to focus on Neofabrae vagabunda, Penicillium expansum, Botrytis cinerea, and Fusarium avenaceum of apple fruits. Our activities, so want to use mainly for the kiwi fruit part the use of brassicanid grass seeds power through the biofumigation experiments, and through dipping on calcium chloride and hydroxide calcium against Cadophora luteolivacea, and both these kind of experiments will be conducted by in vitro and in vivo assays. And about the use, the control of palm fruits like apple against Neofabrea, Penicillium, and Botrytis and Fusarium, we decide to use some essential oils from organic cultivation. So I hope that is all.
Yeah, thank you, Alessandra. And Have a nice work in the field. We envy you looking at that very nice sea behind of you. So
Thank you.
okay, thanks again. So let's move to Milano. So University of Milano, Professoressa Silvia Toffolatti with Giuliana and Demetrio. Silvia, welcome.
Good morning. So, hello to everybody. I'm Silvia Toffolatti from the University of Milan. Our university is located in northern Italy. It's a very nice city. Actually, we are close to the mountains, close to the lakes, not far from the sea. And we are standing in a very important agricultural
Not far from the
area.
sea is not completely true.
Not far, it's one. Oh, well, it depends on the traffic.
Okay.
Because in 1 hour you can reach Genoa, so it's not so far. But it depends on the traffic. It can also take 4 hours to reach Genoa, it depends. But it's in a very good position also in concerning agriculture. I'm working with, I am an assistant professor and I teach grapevine disease management to the bachelor students. And I'm working with my collaborators that you will meet during the next phases of the project. You will meet then Giuliana Maddalena. She's a postdoc student since 4 years in our lab. And then you will also meet Demetrio Marciano, which is a PhD student who just started his PhD studies. In our research activities, we mainly concentrate on plant disease management, on phytopathogenic fungi, in particular on oomycetes, and we mainly concentrate on grapevine disease management, actually. Our studies focus on the research of new active ingredients with low environmental impact, but we also deal with fungicides because they are used and they must be used correctly. So we also have studies on fungicide resistance and on its management, and we also carry out field studies on this topic. We are currently mainly focusing on plant pathogen interaction, and I will show you later. And we also deal with epidemiology and population genetics. Our activities are carried out in the lab, of course, in the greenhouse, but also in the field where we compare the effectiveness of anti-resistance strategies for fungicide management. Here is a brief list of our recent studies published in the last 3 years. As you can see, we are mainly focusing on plant pathogen interaction, and in particular, we are investigating the resistance mechanism of Vitis vinifera, the European grapevine that was considered susceptible to Plasmopara viticola, the agent of downy mildew. And we discovered a cultivar, which is called Megaloblishvili, that has interesting resistant traits against Plasmopara viticola. And now we are studying how to exploit these resistant traits for a more sustainable disease management. And one interesting thing that we are doing, and it's also important for this study, is how to exploit the terpene compounds synthesized by Megaloblishvili to counteract the action of Plasmopara viticola. We discovered that there are 4 terpene substances that can be effectively used against Plasmopara viticola. In the Euphresco project, we will mainly focus on 2 important pathogens of grapevine that are causing downy mildew, and you can see here on the top left panel the symptoms of grapevine downy mildew. And you can see that the pathogen is Plasmopara viticola is able to infect all green parts of grapevine, leading to losses in the quantity of the yield, but also in the quality of the yield, because it's affecting the leaves, and so less sugar are accumulating in the berries due to the loss of photosynthetic activities. And then we will concentrate also on botrytis cinerea. This is a pathogen causing gray mold, and here you can see the symptoms on the berries of grapevine. What we will try to do is to evaluate first in vitro condition the effectiveness of some substances that are listed in the bottom table, such as clade carchol, diammonium phosphate, sodium chloride, sodium hydrogen carbonate, and calcium hydroxide, against Plasmopara viticola and Botrytis cinerea. First, we will do in vitro assays, and then if they will be successful, we will move to greenhouse and hopefully to field conditions. Thank you very much for your attention.
Thanks to you for this very nice and interesting data to done and to be done. So
yes, we are at the start.
I'm sure that they will add some very important experience to the project. So let's move to Professoressa Clemencia Chavez Lopez from University of Teramo. Hi, Clemencia.
Hi, everybody. Wait a minute, please. Okay, I share with us. Sure. Okay, I'm from the University of Teramo. And our research group belongs to the Faculty of Bioscience and Technology for Food, Agriculture, and Environment. We are located in the Abruzzo region, in the center of Italy, and precisely in the Teramo city, a very nice city. And we are very near to the sea. Okay, and together with me, the Professor Antonello Paparella, Analisa Serio, Dr. Clara Rossi, and Junior Molina Hernandez. You can see here. Okay, will be work together in this project. Our research line, as you can see, are regarding principally to food safety and also microbial ecology. As regards food safety, we are focused overall to study the impact of the new technologies to improve the shelf life of foods, studying overall pathogenics and spoiling bacteria and fungi like target, and the agents that we use are essential oils and plant extracts, chitosan, peptides, nanomaterials, and in the last year we are studying also the effects of the cool plasma and pulse vacuum on the microorganisms by means of several approaches. These approaches are studying the microbial survival and also the growth in both in vitro and in foods. And also we study the mechanisms of inhibition, as well as we study the metabolomics and the molecular responses to sublethal stresses when the microorganisms are subjected to the different antimicrobial agents. As regard, I have a problem, excuse me, because, okay, here. The studies of microbial ecology are focused on the study on biodiversity and also the function of the microorganisms that are associated particularly with meat products, dairy products, seafoods, and vegetables. And in this project, our group will be focused on tropical fruits that already we are working together with Jamie and Professor Gianfranco, and also post-harvest decay agents. Our activities are involved in the Work Package 1 review of application of potential basic substance, the Work Package 3 and 4, testing basic substance, and also, and also the Work Package 6 investigation on mechanisms of action of basic substance. And excuse me. Okay.
Thank you, Clemencia. You have a last slide. That is very nice, with very nice pictures. I think from Teramo. Okay, this is okay.
It's also very interesting because this is Teramo, and look, this is the view from our laboratory of microbiology. So with this picture, I say thank you very much, and we wait for you here in Teramo.
Thank you to you, Clemencia. Great presentation. And so we can move to Torino. So there is Monica Mezzalama, and that is part of the team with Davide Spadaro. Monica, are you here?
Yes, I am here. Good morning, everybody. Davide is not here this morning. He has to teach, but I hope I can fulfill my task even without him. I will share the presentation. No? Può mica andare fuori, Laura, per favore? Può mica uscire? Grazie. Let me share. I did it already. Here it is. And okay. So my name is Monica Mezzalama, as Gianfranco has said. And can you see my?
Yes.
Okay. I don't know. Are you seeing a full screen?
Yes.
Okay, good. So I joined the University of Torino and AgroInnova, which is the Center of Competence for Innovation of agro-environmental field here at the University of Torino in 2019. So I have a different background from the group where I work at the moment, but I will talk about it in a second. AgroInnova is located in a campus close to Torino. We are not close to the sea, but we are close to the mountains. So you are very welcome anytime for hiking and skiing and whatever, as soon as we can. And we are on a campus close to Torino, as I was saying, where there is also the faculty of, the Department of Veterinary and of course of Agriculture. AgroInnova was funded in 2002 and it has different aims, of course, basic and applied research in agriculture, but also technology transfer, training, and dissemination and communication. AgroInnova is not involved really with academic teaching, but both Davide Spadaro, myself, Professor Gollino, are, of course, professors at the university teaching plant pathology in different areas. The research activities of AgroInnova are very different, starting from studying new and emerging plant diseases, epidemiology of plant pathogens, effect of climate change on plant pathogens epidemiology, disease management, where a lot of work is done in biological control and integrated pest management. We work also on mycotoxins and food safety in general. And as far as I'm concerned, I work in seed health. There are several projects that AgriNova has on one side coordinated or participated as a partner, where biological control of several pathosystems was one of the aim of the project. So we have emphasis where we were coordinators and where soil-borne pathogen, airborne pathogens were addressed in terms of diagnosis, but also in terms of biological control with microorganisms and natural products and compost in soil. At the moment, we are involved with a project called Excalibur, where we are targeting specifically pathogens at the below ground level on different horticultural crops, among them strawberry, tomato, onion, and others. And we are involved also in a project which is called Clean Fruit, where we are targeting post-harvest pathogens under a zero residue strategy. So mainly using antagonists and natural products such as also chitosan, for instance. We have other projects involving grape, because grape is a very important crop in Piedmont, the region where Torino is located. And we are addressing the issue of copper being phased out, and therefore we have several trials going on in different projects regarding the use of microorganisms like, for instance, Bacillus or Trichoderma, and natural products. Here we have a very important, just to give you an example of the area of research of Davide Spadaro, regarding the use of this yeast that has been already tested since several years ago, and EFSA is already evaluating the risk assessment regarding the use of these microorganisms in post-harvest. So we intend to proceed in this with this research. Also, I didn't mention here, but we have some work done also with the use of essential oils in post-harvest, and also in that case we intend to go ahead with that subject. As far as the seed, we have put our interest in using biological control strategies for seed health. And this is a very important area that it's started on cereals with my arrival in 2019, and that was also it was going on already on horticulture crop, of course, before my arrival. So in this sector we have some experience with seed treatments with some essential oils and some other natural products, and we have some experience in let's say biological control at the soil level with the use of amendments and some organic compost that have a suppressive action. That's it.
Thank you, Monica, for the very interesting and nice presentation. And now let's move to Verona, where Nicola Mori is booked, but there is Corrado Perin, right?
Yeah. Thank
Corrado.
you.
Hi, Corrado, welcome.
Thank you. I'm going to share my screen. Okay. So a bit rusty. Thank you for introducing me. And my name is Corrado, and today I'll speak for my professor, Nicola Mori, from the University of Verona. And I'm going to talk to you about some strategies we are studying for the
Sorry, Corrado, we saw just the miniature, but okay, very good. Go on.
Okay, because I have two screens, so I don't know how to handle it. Anyway, we're studying some strategies as an alternative to the use of synthetic insecticides for the control of Bactrochera ole in the field, the olive fruit fly. I need to mention that in this topic, we are also deeply collaborating with the University of Padua, with Professor Luca Mazzoni. I want to start with a brief introduction about the topic. So why we are studying Bactrochera ole. Basically, the olive cultivation is widely spread in many regions of the globe, and it's very important across the Mediterranean basin. But whenever you see an olive orchard, you can also find its enemy, I would say our enemy, which is the olive fruit fly. The larvae of the fly feed on the pulp, and it has been estimated that the production loss is around 30% each season, but it can also reach the 100% of olives attacked. So far, the traditional control was based on the use of insecticides, for example, dimethoate, which is an organophosphate. And actually, this insecticide was really appreciated by farmers because it has a high efficacy against the olive fly, even when the infestation is high and ongoing in the season. The problem is that dimethoate was banned in 2019 by European Union. So we really need alternatives to these insecticides, to synthetic insecticides in general. And here we are. We are working on two main aspects. The first one, the one in the left, is the oviposition deterrent effect of some commercial products, which are not known for having such effect. So, for example, I'm talking about elicitors or products coming from the industrial waste. Here we see the wastewater from the olive milling, for example. And the other aspect, one on the right, is the symbiotic control of the primary symbiont of the fly, of the olive fly, which is the Candidatus erwinia tacicola. This bacteria is essential for the survival of the larvae on the unripe olives. And this bacteria is vertically transmitted to the progeny. So the fly leaves some bacteria on the surface of the egg, and the larvae gets the bacteria after hatching by ingestion. So we're working on the disruption of the vertical transmission of such bacteria. So killing the bacteria on the surface of the egg by treating the egg or treating the olives. But we're also carrying on some tests about the isolation and the cultivation of the bacteria in vitro. And it might open, in case of success, to a lot of other possibilities of the experiments. And basically, that's all. Thank you.
Thank you, Corrado. And it is great to have within the project also a part of pests, because those basic substances, as Patrice told, can have target fungi, the contamination of surface, but also pests. So that's important. And I welcome all the other colleagues that reached us in the meantime. And now is the turn of Porfirio Gutierrez Martinez from Mexico. So let's fly through Atlantic and go back on the other side. Welcome, Porfirio. It is early morning by your side, right?
Yeah. Sono le 3 della mattina. Okay, let me. Good morning, and my name is Porfirio Gutierrez Martinez. My institution is in Nayarit State in the north of Mexico, very near of the sea, of the Pacific Ocean. We have the condition for tropical and subtropical fruits, mainly this type of fruits is jackfruit. Is fruit very large, with more or less 6 or 8 kilograms. And other tropical fruit very important for us is Annona muricata, guanábana, and banana, avocados, and other tropical fruits. We have many problems with the post-harvest disease and post-harvest fungi. Nayarit States in Mexico is the main producer, jackfruit and guanábana, Annona muricata, and avocado. And we would need to work to present alternatives for the fungi synthetics. Our program is finding new and novel alternatives to synthetic fungicides for control of post-harvest disease in tropical and subtropical fruits. My research group and professor and student of Master of Science and PhD students in foods, we have some research and studies on fungicide of plant and animal, including ethanol, hot water, plant extracts, essential oil, phytosan, organic cell, silicate, alone or combinate, among others. Our group is always involved in the induction of mechanisms of resistance in tropical vines, and we try to know what happens in morphology and physiology in the main post-harvest fungi, like Coledotrichum, Rhizopus, Alternarium, Botrytis, etc. Some results of our works in some years, mainly in mango. Mango for Mexico is very important. Avocado is like avocado work with the United States. Nayarit is more or less 5 hours from the border of the United States, and is very important the integrity of the fruits. And this is the last work in our lab, and we have worked with sodium silicate and chitosan in combined form, and we have a good results for the next parts and the in vivo studies for another students in PhD. And the most important part is my students and my professor who work in research groups, and it's very nice to see the heroes of our lab, my students. It's all, Gianfranco.
Thank you
very much.
Thank you to you, Porfirio. Thank you very much to you for this very nice presentation of your activities. I love mango. So we need to protect it from disease because we have to eat. Very good. Let's fly back to Europe. So it's the time of Poland. So Jolanta Kowalska.
Hi.
Hi, Yolanda. Welcome. The floor is yours.
Okay. Thanks you. Hi everybody once again. Sorry, I'm so sorry that I don't have my presentation, but I want to say you some information about me, about my department and my institute, and also about our activities. I am head of Department of Organic Farming and Environmental Protection. We work at Institute of Plant Protection of Poland. We are located in the west part of Poland. My institute is governmental body, and my department is also mainly included in activities related to organic crops, to organic farming, to protection of organic plants. Until now, we had many projects, both national and international projects, both dedicated to basic and implementation research aims or goals. Until now, we work on basic substances mainly with cinnamon. This is candidate for basic substances. We have many research tasks for mustard meal. These substances we used mainly to dressing seeds and also towards to foliar application in field crops. Because our institute work mainly on arable plants, we have experiments with potato, with cereals, with rape plants, and these plants are a main topic of my research. What also? Also, we work on many different areas, mainly on non-chemical methods used to protection of crops. We used many alternative substances, natural products like water plant extracts, like chitosan, like oligosaccharides. We used many yeasts also to protection of plants in field conditions, also in storage experiments, and until now we want to participate in this project in focus of use chitosan and allium cepa extract and sunflower oil used against Phytophthora infestans, because pathogens of potatoes, Alternaria sorania, Alternaria alternata, and Phytophthora infestas, we want to test in this project and used and substances natural and basic too. This is in brief what we did and what we want to do. Thanks.
Thank you, Yolanda. And if you want to summarize in 4 or 5 slides those activities, all of you can send me the PDF or PowerPoint and we can upload on the website.
Okay, I do it.
Thanks again. And now there is Pervin Kiney. Let's jump to her. She is in a meeting, so she just had a break in a meeting. So I give the floor to Pervin. Hi, Pervin. Welcome.
Hi, everybody. Hi, Gianfranco. Thank you so much to give these opportunities. I'm Pervin Kiney Tekser. I'm from Turkey, Ege University in Izmir. I'm working on mainly post-harvest diseases. Also with Gianfranco, we have a project. And in this project, we will work with sodium bicarbonate and post-harvest disease of citrus and other crops. Last week, we start to work with oranges and just in the storage period. Now we are in the close-up stage in Turkey. Because of this, all the studies are stopped now. But next week we will go to the work again, and we will go on. I will send my result and pictures to you as a PowerPoint presentation. Thank you.
Thank you, Pervin, for this very brief but effective presentation.
Yes.
And we will have time to read carefully and even to see again the video in case you are interested. So let's move to Luis Gonzalez Candelas, that is with Anna and is part of XIC, a composite unit. There is another unit in Logroño. So Luis, the floor is yours. If you want that we hear you, you have to turn on the microphone.
Do you hear me now?
Yes.
Okay. Okay, I will share my screen. Okay. Okay. We work in Valencia. It's located here on the east side of Spain, on the Mediterranean Sea. And this is the major citrus producing region in Spain. So most of our work is dealing with citrus, post-harvest citrus, and their pathogens, as you will see. We have different fields on which we are working. Mainly on post-harvest fungal pathogens, penicillium, basically digitatum or expansum, analyzing the molecular basis of pathogenicity and the virulence mechanism, trying to get information, knowing the mechanism, and see whether we can use that information in order to combat the pathogens. But we also work on the fruit side. Not as much as in the pathogen, but we also work on fruit resistance, inducing resistance by either physical treatments, as curing could be, or blue light. LED blue light is a new source of resistance in fruits. We study also the hormonal and chemical inducers of resistance. And the latest aim is to put together all the information we can gather from either the pathogen or the fruit in order to develop alternative treatments. Basically, we are following two different lines: biological control and testing new compounds. That is the topic more related to the basic projects. And finally, we are also working on mycotoxins, because some of the pathogens we are working with are mycotoxin producers. We are also studying fungi and the mechanism of mycotoxin production. We face these studies on pathogens basically using genomics, transcriptomics, molecular biology methods. Okay. As I told you before, those are the pathosystems we are basically working with. Oranges, citrus in general, with the two major pathogens, digitatum and italicum, that are non-mycotoxogenic, but we also work with Penicillium expansum and Grisopulbum, that are pathogens. Expansum is the major pathogens of apples, and is a mycotoxigenic fungus that produces patulin and citrullin. And lately, we are also working with Aspergillus carbonarius, that is a big producer of ochratoxin A. Okay, the kind of studies or the approaches we conduct with this specific filamentous fungi are genomic characterization. We have worked on the genomic characterization of the three major Penicillium post-harvest pathogen, Italicum, digitatum, and expansum is apple. Working on different aspects of genomic characterization, functional analysis, transcriptomic. Also, we are developing tools to conduct genetic manipulation of these fungi in order to study possible determinants of pathogenicity and virulence, and as I told you, we are now trying to develop new control treatments alternative to conventional fungicides. In relation to this, we are working with chelators, compounds that are able to quench, to sequester metals. This is an example of a chelator that we found working with proteases as an inhibitor of proteases, that is phenanthrolene, that is very, very effective protecting both citrus and apples against infection by digitatum or expansion. This is a chemical compound, but we think, and this is our bet, that EDTA and other additives can be used as chelant in plant protection, in post-harvest protection. And this is our main contribution, or what we want to conduct in this basic project, to analyze the EDTA as a possible basic substance in preventing post-harvest diseases of citrus and apples, and study the mechanism of action of this compound. This is all. Gianfranco, come back to you.
Thanks, Luis. Great presentation and very interesting results, and room for the discussion of the afternoon. Now there is the turn of Mohamed Beshi Alagui, so let's move to Tunisia. Mohamed, are you with us? I don't see his microphone. Okay, let's wait that he sets the system, and now is the time of Simona Sanzani from CEAM in Bari. Welcome, Simona.
Thank you very much. Sorry. Do you see the screen?
Yes.
Okay, fine. First of all, it's very nice to see all these colleagues and friends connected. So I'm very pleased to take part to this project and to this meeting today. Thank you very much for this opportunity. First of all, I want to say a few words about my organization. The CEAM is an intergovernmental organization founded in 1962. It involves 13 countries as members in the Mediterranean area. It has a general secretariat located in Paris, and has 4 Mediterranean Agronomic Institute located in France, Spain, Greece, in Italy, near Bari, from where I come. Our institute is in Bari, has several duties, let's say, several focus. One is the education, since we have 3 master courses, one in integrated post-harvest, integrated management of plant pathogens. Then we are focused on training personnel of Mediterranean areas. We are focused on applied research and international cooperation activity, and everything is meant to promote, to sustain the institutional dialogue among countries of the Mediterranean area. I entered the CEAM Bari in 2019, so it's not a long time as a scientific administrator, but I've worked since my PhD on post-harvest management of fresh fruits and vegetables, and that's why since my entrance in CEAM Bari, I tried to build up with the help of my colleagues small post-harvest groups, and we hope to grow faster in the next years. Our idea for participating to this project is to focus on a basic substance which is already recognized, which is sodium bicarbonate. But we would like also to focus on possible candidates, including other salts as potassium bicarbonate. And we will be very pleased to work on also another possible candidate, which is moringa oleifera extracts, an activity that we will conduct in cooperation with some colleagues from a Tunisia institution, which will support us with their knowledge. And the idea is to use these treatments on commodities, some peculiar of southern Italy, as citrus fruit in general and mandarins in particular, sweet cherries. Apulia is quite famous for sweet cherries, and also for the production of tomatoes, basically because, as I said, these fruits are relevant for our economy, but of the economy of the several other Mediterranean countries, but also because they are subjected to some post-harvest treatment as dipping and washing water. That's why maybe they would benefit from the use of disinfecting agents. So our idea would be to test them as post-harvest treatments. We would be interested not only in classical post-harvest pathogens, but also pathogens emerging even in post-harvest as alternaria, and also able to produce mycotoxins, which is one of my favorite topics since ever. And we would like also to think to this treatment in a combined strategy of application following a pre-harvest application of alternative control means in cooperation with the University of Bari Aldo Moro. And we would like to also to perform some quality analysis to evaluate the effect of this treatment, not only on the disease, but also on some relevant quality parameters, including consumers' appreciation. And basically, that's all. Thank you very much for your attention with this little bit of Bari. And so you are very welcome to visit us. Thank you very much.
Thank you, Simona, for this very interesting show on your activity. And all the presentation will be available on the website and will be advertised through social media. So thanks to all of you for this very good introduction of the project. So this part of kickoff can be concluded and we can go on with project activities. So